Okay, so let's start. Today, briefly, I wanted to tell you about how cloud works, very basic concepts, what a lot of people are missing actually when thinking about cloud. So let me start. Again, very quickly about me, 12 years in the same company, 12 years working with Linux and virtualizations, which are actually bedrock of the whole cloud concept. And around 4 years ago, I moved purely to cloud, working with OpenStack, Google Cloud, and mostly AWS, Amazon, web services. As you can see, I'm Linux certified, which was very handy when I moved to cloud because, like I said, it's a building, one of the building blocks of every cloud. And I'm something called O5 AWS certified, which was true till the end of the last year, I believe, when AWS introduced 3 additional certificates that I need to get, but I'll be there at some point. So next 25 minutes, questions at the end, please, and we'll talk about 3 things. So first one is cloud versus virtualization. So how is it similar? How is it different? Another thing will be cloud building blocks. They're really basic blocks based on AWS, but they're really applicable to all other cloud providers. And the third one will be cloud applications. So let's start with cloud versus virtualization. Many technical people that I know, they think they understand what cloud is. Yeah? In their minds, very often, surprise, surprise, it's wrong. Cloud is virtualization, which is obviously incorrect. Virtualization to cloud is what brain is to human being. It's an essential block, yes, it is, but the cloud or human being is much more than that. And here I'm not trying to say that women do not have brain, obviously. That's me just trying to say that it's much more to human than just a brain. If aliens would land today here and they would ask you, describe me a human, and you would just describe them a brain and said like, now put it in the biological body, that doesn't, describe the whole complexity of humanity, correct? So virtualization to cloud is what brain is to human being. It's a heart of it, it's an essence, but it's much more than that. So when we are talking about cloud, I think it's good to have some definitions. So this is one of my favorite definitions of what the cloud is by Titus Korek. He's a PhD in cloud. He's my close friend. So let me just read it quickly. It is completely transparent to users. It delivers a value to users in the form of services. Its storage and computing resources are infinite from users' perspective. It's geographically distributed. It's highly available. It leverages computer network technologies. It leverages virtualization and clustering technologies. It's easily scalable. It operates on the basis of distributed computing paradigm. It implements pay-as-you-go billing. It's multi-tenant. And the last one, which I don't fully agree with, it runs on the commodity hardware. Yes, to be fair, Titus is right. 99% of cloud providers does run on commodity hardware, but it's not a must-have. So when we are talking about cloud and all this concept, it's just good to quickly talk about servers, virtualization, and containerization. So in the old school approach, you had a server. If you don't know what server is, just imagine your laptop, slightly bigger, put it in the separate room. That's a server. So take this server, install any operating system on it, Linux, Windows, macOS, whatever you want, and then you install your applications like Microsoft Excel, Microsoft Word. But what happens if you want to have 10 exact same versions of Microsoft Word on a single server? It's impossible. They will collide with each other. So if you want to have 10 separate Microsoft Word versions, what you need to do is you need to have 10 servers. Yeah, this is basically waste of resources. So that's why virtualization had been invented. So virtualization on the same server, you install the same operating system, but then on top of it, instead of installing just app, you install something called hypervisor. So hypervisor basically emulates a hardware. It pretends that it's a server. And you have something called virtual machine. Yeah? So virtual machine, very important thing. In most of cases, like in Matrix, it's not even aware that it's a virtual machine. It really thinks that it's a real server. Yeah? So on virtual machine like that, you install again operating system and your application. These virtual machines don't touch each other. So you can have your 10 words application on 10 separate virtual machines running on the single server. So that was definitely a step forward. But there is a next step in this evolution. So someone looked at this drawing probably and noticed that there is plenty of operating systems, plenty of duplicates here. So the next step was containerization. Very similar concept. You take the server, install operating system like Linux, then you install container engine on it, like Dockers, and then you install your containers with separate apps. Yeah, that's much more cost effective. The one downside of containers versus virtualization is that this can be Linux, this can be macOS, this can be Windows. Here, all applications needs to run on this operating system, so they need to be compatible with, for example, Linux. And by the way, if you just take this server and you put it in someone else's data center, this doesn't make you cloud. This just means that your server is in someone else's data center. That's it. If you take your VMs and put it on someone else's server in someone else's data center, it doesn't make you in the cloud. It just makes your VMs to run on someone else's data center. The same with containers. Yeah. So these are the basic building blocks, of the infrastructure of the cloud. Now let's look at building blocks that the developers are using. We will look at Amazon example, but this is completely applicable to Google Cloud, Alibaba, or Microsoft Azure. These are the big players out there. Availability zone. Availability zone, simply saying, is just data center. Whenever you see in the movie, data center, plenty of servers, something beeping, something blinking. That's exactly how data center looks. Hundreds and hundreds of servers which run hundreds of VMs and containers. Yeah. Now, collection of data centers, called this availability zone, AZ for short, that are geographically close nearby, like 100 kilometers away from each other. It's called region. So region consists of minimum 2 availability zones just for availability, usually from 3, sometimes from 4 or even more. And these data centers, these availability zones, are connected with a very fast internet connections. Yeah, they act like a single organism. And when you look at AWS services, some of them they're living on different levels. Yeah, some of things like virtual machines, they live on the availability zone level. So when I would be deploying virtual machine, I would say, give me this virtual machine in region Frankfurt in AZ2. I need to specify that. But there are services like load balancer where you just specify, like, give me load balancer region Frankfurt, and then the magic happens. So these 3 zones could go down, I don't know, bomb, whatever, yeah, and my load balancer would still be up because AWS, assures me that it will run in the region. Now, how does it look from the world perspective? Where is the cloud market actually growing? Yeah. When you look at this, the 4 most important cloud markets are US and Canada, obviously, EU and France, China and Taiwan, and India. And obviously the rest of the world has plenty of regions there. This is actually number of regions, yeah, but they are not driving this market. This market is driven partially by politics. So, for example, European Union has a law saying that if you have very fragile, very important data, they never can leave European soil. Yeah? That's why the data centers, availability zones, and regions needs to be located here. But it's not only EU. Yeah? China, India, and especially US has really similar laws. So that's why these regions are located in these places. Now let's talk about very basic building blocks. So whenever you hear something called EC2, that's basically managing of VMs that we are talking about. VMs in cloud are called, for strange reason, instances. Yeah? So this instance equals VM. That's it. And the cool thing with VM is that if you turn it off and you keep it as a file somewhere, it becomes image, and from this image you can have multiple copies of the same VM. And actually, when you are creating a new VM or instance in AWS, you are asked what image you want to use. So you can obviously select like a default image that's provided by Amazon with naked Linux, or you can have your own image with your application preloaded there. Whenever you hear ECS, that's exactly the same concept, but with Docker containers, not with virtual machines. The next one is ELB and autoscaling. So ELB is just elastic load balancer. If you're not familiar with load balancer concept, that's very simple. Yeah, you have one input, usually with one name like www.google.com. You just go there, and then traffic, you don't see it as a user, is forwarded to some other instances or containers that are there below. But with cloud, you get one more really interesting feature connected with load balancer. It's called autoscaling. Based on some metrics, in this case, let's assume based on the amount of traffic coming to the load balancer, you can add or remove more instances based on your image that you prepare. This is pretty cool, and this is very cost effective. Storage. There are a couple of different storage solutions that you have in AWS. First one is RDS. It's Relational Database Services. So basically, this is Oracle, Postgres, MS SQL, MySQL as a service. Traditionally, you just install it, you manage it. In AWS, you just say, give me Oracle version something with 16 gigs of memory, and it just happens, automatically. And it's actually highly available. It's spread across availability zones in a single region. But there is the next step, Aurora. This only works with MySQL and PostgreSQL because they are open source. So AWS modified the code of these databases so they're so they work better with clouds. They are faster, they are cheaper, they scale out. So this is amazing technology. There is also a mother or father of all NoSQL databases. This is one of the first NoSQL databases that were out there. A lot of other NoSQL databases were basically clone of DynamoDB, which is the very famous NoSQL database that Amazon offers as a service. Another very famous example, S3. S3 is a file storage. On the left, you see databases. On the right, you see the storage. And I'm not sure if you heard about, solution like Dropbox. The only thing that Dropbox did, and still does, they just created UI for average users to upload files to S3. They don't own any of their own servers. Everything is just Amazon. This is just the front end. This is just their whole business model. So the difference between these two, obviously databases are very fast, but they cost money. With S3, it's inexpensive, it's very durable, but it's very slow. So whenever you are designing a new solution, that's the choice that you need to make. What's your storage? My personal favorite, CloudFormation. So this helps with DevOps a lot. One of the bases of DevOps is that developer needs to develop code on the environment that's identical to the productional environment. Traditionally, it's very hard. You develop on your laptop, then you ship it to a server that's completely different and something breaks, because infrastructure is different, With CloudFormation, which is actually a language, declarative language, programming language you could call, you can define your infrastructure in AWS. It looks like that, I mean, it's a bit more complicated, but you get the picture. Create 2 instances, make them large, use my image, add to this load balancer with this DNS name and configure my network. So you just save this file, you execute it against AWS, and AWS creates infrastructure for you. And the cool thing, you can execute it the second time, you can execute it the third time, and you will get exact the same environment. So developer can take file like that production is configured with, and they can have exact the same environment to do their testing or development. Another interesting thing happened with this one. In old school approach, if I would need to add another server, I would need to buy it, take it, move it to the server room, install it, connect cables, etc., and just give it to developers. Today, there is no need for that. Today, it's called infrastructure as a code. So developers can manage their infrastructure by their own, because it looks similar to any other programming languages. Like you can manage like Java or Python application. You put it in the source control, someone needs to review it. You don't do manual changes. It goes through the whole development process. So this is very critical for DevOps. And that's about the most important building blocks. So now let's try to put some application in the cloud. Let's start with Word application. We all know how it works. It's just a Windows application. You install it, then you open it, edit some file, save it. Simple. Let's now assume that you want to put it in the cloud. What do? You just take instance, yeah, from the Windows image, you install their Word, and that's what you have. You can save it as your pre-configured image for later. You don't have to, yeah? Then you just connect to it using external IP address or external name. You log in there with remote desktop or something like that. You edit your file, you save it. That's cool. But AWS doesn't promise you, they do not commit that the instance will be alive. They actually say that at any moment of time, the instance may go away. They do not guarantee that it will be alive. Of course, availability zone, one of the data centers may go down completely. That happens as well. So what do? You just build another one using your image in the other availability zone, yeah? So you log into the first one, edit some files. For some reason, it's unavailable. So you log into the other one, you want to continue editing your files, and what happens? Nothing happens. Files are not there. Files are stored locally, so they are gone. They're inaccessible for you. So we need to introduce another concept, very basic again, shared storage. So you make your instances, actually Word application, not to write files locally, but to save them to like S3 bucket or something like that. That's cool. That's highly available. But what if you have, I don't know, 100 users? Just what? Create more of this, and you expect users to remember all of these different names that they have to log in. You expect them that if this goes down, they need to know that they should have tried the other application. This is not the cloud experience, yeah. So what you usually do, you put a load balancer, in front of it. So users have single point where they go, and then traffic is distributed. And actually, you can set up auto scaling, yeah. So the more traffic coming in, more users trying to come in, you spin up more instances with your Word application. But here's the problem. Load balancers are mostly about web traffic. Microsoft Word is not a web-based application. You cannot access it from your browser. Yeah? It's just a Windows app. So this will not work. End of story. Yeah? But let's assume for a second that it does work. Okay, it does work, and two users logging at the same time, to different instances, and they try to edit the same file. What happens? Microsoft Word doesn't support it as well. Is there a cloud solution for this one? There isn't. So the only solution is to take this application, Word application, and rewrite it in a way that it's web-based and that it allows you to edit the same file at the same time. And funny thing, this is exactly what Microsoft did with Word. There's a Word offline which is rewritten to be web-based, and you can edit the same files by multiple people. That was a necessity. Yeah? This is very important thing to remember. You cannot take any application and just move it to the cloud. It's not like that. Application needs to be modified or written to work in the cloud. That's when you are getting real cloud experience. I will try to give you some analogy. Let's imagine that my dream since I was 5 was to be in jail. Okay, strange dream, but let's assume one. So I would walk out from this room, go to the closest jail, knock to the doors, someone would open the door, I would just take a step inside, and I'm in jail. Really? That's the in jail experience? Yeah? The fact that I'm in the building called in jail doesn't make me actually to be in jail. It's much more than that. The same with applications. If you move some application to cloud, it doesn't make it in the cloud. I know that it sounds funny, but it's true. So, just to sum up, cloud is much more than just virtualization. Yes, virtualization is essential and critical part of it, but it's much more than that. Second, there are tens, if not hundreds, of AWS building blocks called AWS services. Yeah, but the most essential one are EC2s that are managing your instances, VMs, ECS that are managing your containers, ELB that is basically your load balancer, S3 for storing your files, RDS, Aurora DynamoDB to be a DB as a service, auto-scaling to add or remove machines per some metrics, and CloudFormation that allows you to manage infrastructure as a code. Third thing, apps need to be cloud written. You cannot take any app and put it there. It doesn't work like that. 2 next steps for you if you are interested. One thing that we haven't even started to talk about is called serverless. So imagine that you write your application and you don't need any server. You don't need any virtual machine. You don't need any container. You just put it in the cloud and it works. That's called Lambda. Google it. It's really cool. Second thing, I would really like to encourage you to get AWS certified. You don't have to go with this all five, of course, but there is a very entry level, very simple exam, that you can take. It's called Cloud Practitioner. You can learn it, I don't know, in 20 hours. It's not very technical. And the cool thing about this one is that when you get it, you get a really cool sticker. I have more of that on my laptop if you are interested. Yes, so that's all I wanted to tell you about cloud. I hope you enjoyed it. And questions?